In 1967, a physicist named Bryce DeWitt published a paper in Physical Review, volume 160, pages 1113 through 1148. The paper was titled Quantum Theory of Gravity, Part 1, The Canonical Theory. It was dense, it was technical, and buried in its pages was an equation that should have changed everything. The equation was simple to write down: h psi equals 0. The Hamiltonian operator acting on the wave function of the universe equals 0. That is it. That is the whole thing. And if you are not a physicist, that notation means nothing to you. So let me tell you what it actually says in plain language, because what it says is the reason you have never heard of it. It says the universe does not change, not the universe appears to change. The equation says the wave function of the entire universe is static. It does not evolve. There is no time variable in it. Not because DeWitt forgot to include 1, not because he simplified the math to make it easier, because when you take the two most successful theories in the history of physics, general relativity and quantum mechanics, and you combine them correctly using the standard rules of quantization, it is not there, it was never there, the math does not need it, does not use it, and does not contain it. And the people who understood this, the small community of physicists working on quantum gravity in the late 1960s, looked at this result and did something remarkable. They mostly just moved on. They published their own papers. They attended their conferences. They did not hold a press conference to announce that the most fundamental equation of quantum gravity describes a universe in which nothing ever happens, because announcing that would have required them to say something out loud that none of them were prepared to say. That the flow of time, the thing you experience every second of your existence, the foundation of every memory you have, every plan you have ever made, every distinction you have ever drawn between what happened yesterday and what might happen tomorrow, is not a feature of reality. It is a feature of you, something your brain constructs. And the universe itself, the real one, the one the math describes, sits there. All of it. Everything that has ever happened and everything that will ever happen. Not unfolding, not flowing. Just existing. All at once. In a structure that does not move. That is what the equation says. And it has been sitting there, published, peer-reviewed, checked and rechecked since 1967. So let me tell you about the man who wrote it and about the question he was trying to answer when time disappeared from his math. Bryce DeWitt was not born Bryce DeWitt. He was born Carl Bryce Seligman on January 8, 1923, in Dinuba, California, a small agricultural town in the San Joaquin Valley. He was the eldest of 4 boys. His paternal grandfather, Emil Seligman, had emigrated from Germany around 1875. The family name was Jewish, and in 1950, after Bryce experienced anti-Semitism as a young scientist working in Europe, he and his 3 brothers legally changed their surname to DeWitt, taken from their mother's side of the family. This decision would come back to haunt him decades later, when the physicist Felix Bloch, learning of the name change, became so upset that he blocked DeWitt's appointment to Stanford University. So DeWitt went to the University of Texas at Austin instead, where he would spend the rest of his career. He was exceptionally bright. He entered Harvard at 16. He graduated in 1943 with a bachelor's in physics, enlisted in the Navy as a naval aviator during the war, though the war ended before he saw combat, and returned to Harvard in 1946. He began his doctoral work in 1947 under Julian Schwinger, one of the founders of quantum electrodynamics and a future Nobel laureate. And the topic DeWitt chose for his thesis, the quantization of the gravitational field, would become the work of his entire life. Think about what that means. At 24 years old, in 1947, Bryce DeWitt decided he was going to figure out how to apply quantum mechanics to gravity. He would still be working on it when he died of pancreatic cancer in 2004 at the age of 81. 57 years on the same problem. That problem ate his career. When Wolfgang Pauli, one of the giants of 20th century physics, learned what DeWitt was working on during a visit to the Institute for Advanced Study in 1949, he went silent for several seconds, alternately nodding and shaking his head in that famous Pauli way, and then said, "That is a very important problem, but it will take somebody really smart." It was not entirely clear whether Pauli thought DeWitt was that person. At the Institute, DeWitt met Cécile Moret, a young French mathematical physicist in her second postdoctoral year. They fell in love and married. She became Cécile DeWitt Moret, and they became lifelong intellectual partners, her French mathematical formalism clashing vigorously with his pragmatic American approach to physics. They had 4 daughters. They organized the influential 1957 Chapel Hill Conference on Gravitation, and through all of it, Bryce kept working on the same question: how do you quantize gravity? The question that led to the equation came not from DeWitt alone, but from John Archibald Wheeler, the Princeton physicist who had already coined the terms black hole and wormhole, and who had a gift for asking the questions that others were afraid to ask. Wheeler had been pushing what he called geometrodynamics, a program to describe all of physics through the geometry of space-time. And at the 1963 Les Hausch Summer School on Relativity, Groups and Topology, Wheeler posed the challenge directly. If quantum mechanics is universal, if it applies to everything, then it must apply to the gravitational field. It must apply to the universe as a whole. So write me the equation. Write me the Schrödinger equation for the universe. DeWitt did. He took the Hamiltonian formulation of general relativity, the version developed by Richard R. Nowit, Stanley Dazer, and Charles Misner in the late 1950s, which splits space-time into 3-dimensional spatial slices evolving forward in time. He applied the standard rules of canonical quantization, the same rules that had worked brilliantly for electromagnetism and the nuclear forces. He promoted the classical variables to quantum operators. He imposed the constraint equations as operator equations acting on a wave functional. And when he did this, something happened that should have stopped the world. The constraint equation, the one that in classical general relativity generates the evolution of the spatial geometry forward in time, became HCI equals 0. The Hamiltonian operator, acting on the wave function, gives 0, not gives a time derivative of psi, 0. There is no time derivative in the equation because there is no time parameter for it to take a derivative with respect to. The wave function of the universe, psi, is not a function of time. It is a function of the 3-dimensional geometry of space and whatever matter fields sit on that geometry. It depends on configuration. It does not depend on when. DeWitt originally called this the Einstein-Schrödinger equation. It was later renamed the Wheeler-DeWitt equation, which is the name you will find in every textbook on quantum gravity published in the last half-century. And to this day, it remains the closest thing physics has to an equation of quantum gravity. It is not the final answer. Nobody claims it is a complete theory. It is ill-defined in the general case. It has operator ordering ambiguities. It does not tell you how to calculate scattering amplitudes. But it is the equation you get when you do the straightforward, honest thing of combining our 2 best theories using the standard methods. And it says, time does not exist. DeWitt published this in 1967. The physics community read it. They understood the implication. And then, for years, almost nobody wanted to touch it. That silence should disturb you, because the equation was not wrong. Nobody found an error. Nobody showed that time could be restored by a more careful treatment of the math. The result stood. It stands today. And the people who work in quantum gravity know it stands. But talking about it publicly saying in clear language what the equation implies about the nature of your experience, about whether the past is gone or the future has not happened, about whether the flow of time is real or something your brain invented to make a frozen structure feel like a story. That was a conversation nobody in mainstream physics was prepared to have. But a few people had it anyway. The name that physics gave to the problem was deliberate in its blandness. They called it the problem of time, as if naming it would be enough, as if giving it a label and filing it under open questions in quantum gravity could contain the fact that the most fundamental equation in the field describes a universe in which nothing ever happens. In the 1980s, a Czech-American physicist named Karel Kuchar began systematically cataloging the different aspects of the problem. It was not one problem, it was a web of interconnected problems, each one a different face of the same core fact. Time does not appear in the fundamental equations. Kuchar identified and classified these faces over the course of years of painstaking work. Presented at the 4th Canadian Conference on General Relativity in 1992, and in subsequent publications that became required reading for anyone entering the field. Then, in 1993, the British theoretical physicist Chris Isham, working at Imperial College London, published what became the canonical reference on the subject. His paper, Canonical Quantum Gravity and the Problem of Time, which appeared in the Proceedings of a NATO Advanced Study Institute and is archived as Gray QC 9210011, went through the problem systematically and identified its many distinct facets. The paper is dense, technical, and devastating. It makes clear that this is not a minor technical difficulty that will be resolved by a clever mathematical trick. The absence of time from the Wheeler-DeWitt equation is not a bug. It is a direct consequence of the deepest symmetry of general relativity, a symmetry called diffeomorphism invariance, which says that the physics cannot depend on how you label the points of space-time. When you impose this symmetry at the quantum level, time is what you lose. That is worth sitting with for a moment. The reason time vanishes is not some exotic or speculative feature of an untested theory. It is a consequence of the most fundamental symmetry of general relativity, the same theory that gives us GPS satellites and gravitational wave detectors and the prediction of black holes. The symmetry that makes general relativity work is the same symmetry that, when applied to quantum mechanics, erases time from the equations. And here is where you need to correct something you probably think you already understand. Because the phrase time is relative has been floating around popular culture since Einstein, and you might be thinking that this is just another version of that. It is not. What Einstein showed with special and general relativity is that time runs at different rates depending on your velocity and the strength of the gravitational field you are sitting in. Clocks on mountaintops tick faster than clocks at sea level. Clocks on GPS satellites tick faster than clocks on the ground, and the GPS system has to correct for this, or your navigation would drift by kilometers per day. That is real, measured, confirmed physics. But it is physics in which time still exists. Time is flexible in Einstein's relativity. It bends, it stretches, it warps. But it is there. The Wheeler-DeWitt equation says something categorically different. It does not say time bends. It says time is not a variable in the equation at all. Relativity makes time strange. Quantum gravity makes time vanish. Those are not the same claim, and confusing them is one of the reasons the deeper problem has been so easy to ignore. People hear time is an illusion and think of Einstein, and think they already know this story. They do not. The story they know is the appetizer. The Wheeler-DeWitt equation is the main course, and it has been sitting on the table, untouched, for over 50 years. The physicists who work on this problem have a term for the state of affairs described by the equation. They call it the frozen formalism. The universe, as described by the wave function that solves the Wheeler-DeWitt equation, is frozen. It does not evolve. There is no before in the equation, there is no after. There is no sequence of states progressing from one configuration to the next. There is just one object, the wave functional psi, defined over the space of all possible three-dimensional geometries, and it sits there, static, complete, containing everything. If that does not unsettle you, you have not understood it, because everything means everything, not just the current arrangement of matter in the universe. Every arrangement. The configuration in which the dinosaurs are alive, the configuration in which the sun has not yet formed, the configuration in which you are reading this sentence, the configuration in which you have not been born. They are all there in the wave functional, described by an equation that draws no distinction between them, an equation with no ordering, no flow, no arrow pointing from one to the next. Just a static mathematical landscape of every possible state of the universe, all equally present in the solution to h psi equals 0. Now, there was one person who took this completely seriously, who looked at the frozen formalism and the Wheeler-DeWitt equation and the problem of time and said not as a speculation but as a physical conclusion. Time does not exist. Full stop. Not as an approximation, not as an emergent property, not as a way of speaking, as a fact about the universe. His name is Julian Barbour, and to understand why his conclusion matters, you have to understand how he arrived at it, because the path he took is almost as extraordinary as the conclusion itself. Julian Barbour was born on February 13, 1937, in Jerusalem, Palestine. He studied at Cambridge, then went to the University of Munich for graduate work, before completing his PhD at the University of Cologne in 1968 on the foundations of Einstein's theory of gravity. He was on the standard academic track, postdoctoral work, publications, the path toward a faculty position, and then he did something that almost no physicist in the 20th century has done successfully. He quit. Not because he lost interest, because he realized that the question he wanted to answer, the nature of time, was too fundamental and too slow-burning for the modern academic system. Felix Pirani, a general relativist at King's College London, gave him honest advice. If you want a career position, you have to produce 2 solid research papers a year, and do your lectures, and do your administration. Can you do it? Barbour did not think he could, not if he wanted to actually solve the problem rather than publish around it. So in 1969, he returned to the Oxfordshire village where he had grown up. He bought a farmhouse near Banbury using money his father gave him as a way of avoiding death duties. And he supported his family by translating Russian scientific journals into English for the American Institute of Physics and Plenum Publishing. For 30 years, Julian Barbour lived on a farm, translated Russian, raised his children, and worked on the problem of time. No faculty position, no graduate students, no grants, until much later. Just a man at a desk in a farmhouse, thinking about whether time is real. The spark had come years earlier, in October of 1963. Barbour was traveling by train with a student friend to climb the Watzmann in the Bavarian Alps when he read an article by Paul Dirac in Scientific American. Dirac had questioned whether it was correct to unify space and time into space-time. This challenged one of the foundations of modern physics, and it hit Barbour like a physical blow. He never climbed the mountain. He woke the next morning with a splitting headache and spent the rest of the day thinking about nothing except the meaning of time. The article just sparked something in me, he later recalled, and I started saying, "What is time?" That question consumed the next 6 decades of his life. What Barbour eventually argued, in collaboration with the Italian physicist Bruno Bertotti, and then in his own increasingly radical work, is that the universe is not a three-dimensional space, evolving through time. It is a collection of configurations, frozen snapshots. He calls them nows. Each now is a complete arrangement of every particle in the universe, and the collection of all possible nows, every possible arrangement that could ever exist, he calls Platonia. Platonia is not a place in space. It is not a place in time. It is the space of all possible shapes the universe could take. A point in Platonia is one complete configuration of everything, and Barbour's argument is that Platonia is all there is. There is no external time in which these configurations unfold. There is no flow from one now to the next. There is just Platonia, a vast, timeless landscape of possibilities, and certain regions of that landscape are given higher probability by the laws of physics. But here is the part that should keep you awake. Barbour's theory explains why you think time passes, even though it does not. Each frozen configuration contains within it what he calls records. A now that contains a brain also contains within that brain apparent memories of other configurations. Your memory of breakfast this morning is not a causal consequence of an earlier now in which you were actually eating breakfast. It is a property of this now, this single frozen configuration, that happens to contain a brain with that particular pattern of neural connections. You are a time capsule, a structure that contains apparent records of a past that in Barbour's framework did not cause you. You feel like you are moving through time because each now contains records that create the impression of movement. But the movement is not real. The nows are not connected to each other by any flow. They simply exist, scattered across Platonia, each one containing its own internal evidence of a history that never actually unfolded. In 1999, Barbour published The End of Time with Oxford University Press. The cosmologist Lee Smolin called it the most interesting and provocative new idea about time to be proposed in many years. The Association of American Publishers gave it an award for excellence in physics and astronomy in 2000. The book laid out the full argument for a general audience, and it did not hedge. Time does not exist. Not metaphorically, not approximately, not in some qualified philosophical sense. Physically, the equations, Barbour argued, are better without it. But Barbour was a theorist working from a farmhouse. His arguments were mathematical and philosophical. They were compelling to some, dismissed by others, and largely ignored by the mainstream. What the argument needed was experimental evidence, something you could point to in a laboratory and say, look, the Page-Wootters mechanism works. Time can emerge from a static entangled state. The Wheeler-DeWitt equation is not just formal mathematics, it is describing something real. And in 2014, a laboratory in Turin provided exactly that. The idea goes back to 1983, and two theoretical physicists named Don Page and William Wootters. Page was a former student of Stephen Hawking, working at the University of Alberta. Wootters was at Williams College. Together they published a paper in Physical Review D, volume 2007, page 2885, with a title that reads like a koan, Evolution Without Evolution, Dynamics Described by Stationary Observables. What they proposed was elegant and deeply strange. Imagine the universe has two parts. Call one part the clock, and the other part the system, meaning everything else. Now imagine these two parts are quantum mechanically entangled but do not interact with each other. And imagine the total state of both parts together satisfies the Wheeler-DeWitt equation. It is static. It does not change. HCI equals 0. No time, no evolution. The whole thing just sits there. Now here is the trick. If you are an observer inside this universe, correlated with the clock, what do you see when you look at the system? You see it changing. You see it evolving. You see time passing. The correlations between the clock and the system create the appearance of dynamics even though the global state is perfectly static. Time, in this framework, is not a fundamental feature of reality. It is an emergent phenomenon. It is what entanglement looks like from the inside. But from the outside, from the perspective of a hypothetical godlike observer who can see the entire entangled state at once without becoming correlated with either subsystem, the universe is frozen. Nothing happens. Nothing has ever happened. Nothing will ever happen. The wave function sits at h psi equals 0, exactly as the Wheeler-DeWitt equation describes, and time is nowhere to be found. Page and Wootters had proposed a mechanism, a way for a timeless universe to produce the experience of time. But it was theory. Beautiful theory, profound theory. But theory, and theory without experiment, is philosophy. For 30 years, nobody could test it. The problem was obvious. To test the Page-Wootters mechanism, you would need two things. You would need an internal observer who becomes correlated with the clock and sees the system evolve. And you would need an external observer who measures the global state and confirms it is static. You would need to show both perspectives simultaneously in the same experiment. The internal observer sees time, the external observer proves it does not exist. Same physical system, two incompatible descriptions, both confirmed. In 2013, Ekaterina Moreva and her colleagues at INRIM, the Istituto Nazionale di Ricerca Metrologia in Turin, Italy, figured out how to do it. Their paper, Time from Quantum Entanglement, an experimental illustration, was submitted to the Arxiv in October 2013 and published in Physical Review A, Volume 89, Article 052-122. In May 2014, the team included Giorgio Brider, Marco Gramegna, Vittorio Giovanetti, Lorenzo Maccona, and Marco Genovese. The experimental setup was, by the standards of quantum optics, remarkably simple. They used the polarization states of two entangled photons produced by parametric down conversion. One photon played the role of the clock, the other played the role of the system, the rest of the universe. The entangled state was prepared to satisfy the constraint that the global state is static, the laboratory analog of h psi equals 0. Then they ran two kinds of measurements. In what they called observer mode, the experimenter acted as an internal observer. Correlated with the clock photon, they measured the polarization of the clock photon first, which told them what time it is in the sense of the Page-Wootters mechanism, and then measured the polarization of the system photon. What they found was that the system photon state depended on the clock photon state in exactly the way you would expect if the system were evolving in time. The probabilities changed. The correlations shifted. From the internal perspective, time was passing. The system photon was doing different things at different times. Then they switched to super observer mode. Here, the experimenter measured global properties of both photons together without first becoming correlated with the clock. They performed quantum state tomography on the joint state of the two photons. And what they found was that the global state was static. It did not change. It did not evolve. The joint state of the two photons was the same regardless of when the measurement was made. From the external perspective, time did not exist. Both results. Same experiment, same pair of photons. The internal observer sees a universe that changes. The external observer proves it does not. The Page-Wootters mechanism works. Now, it is important to be precise about what this experiment did and did not show, because the popular coverage of it was sloppy. Dozens of articles proclaimed that physicists had proved time is an illusion. That oversimplifies what happened. The experiment demonstrated that the Page-Wootters mechanism works as a description of a specific quantum system. It showed that for an external observer, the entangled state is genuinely static. It confirmed that the appearance of time evolution can emerge from entanglement in a system whose global state does not change. It did not prove that our universe literally has no time. It did not prove that the Wheeler-DeWitt equation is the correct description of quantum gravity. What it did was take an idea that had been purely theoretical for 3 decades and put the first experimental weight on the scale, and that weight has not been removed. But think about the scale of what was demonstrated. The experiment used 2 photons. 2, the simplest possible toy universe. Now consider the real universe. Roughly 10 to the 80th atoms in the observable universe, all of them interacting, all of them entangled with each other in incomprehensibly complex ways. If the Page-Wootters mechanism generates the appearance of time from entanglement in a system of 2 photons, what happens when you apply it to 10 to the 80th particles? You get a universe that, seen from outside, is perfectly static, a frozen wave functional, satisfying h psi equals 0, but experienced from inside as a rich, complex flowing reality full of change and sequence and cause and effect. You get a universe that looks exactly like ours, and the equation that describes it has been sitting in the literature since 1967. The Moreva experiment was published in 2014. It generated some media attention, mostly in science blogs, and a few popular outlets. New Scientist ran a piece. Slashdot covered it. Then it faded from public discussion, not because it was wrong, not because it was contradicted by later work. In fact, subsequent theoretical developments have only strengthened the framework. A 2021 paper by Foti, Coppo, and colleagues published in Nature Communications showed that the Page-Wootters mechanism can derive not just the Schrödinger equation, but also the classical Hamilton equations of motion, all from a timeless, entangled state. And as recently as November 2025, Natalia Aries and her team published a paper in Physical Review Letters on the thermodynamic costs of extracting ticks from a quantum clock, further illuminating the relationship between time, measurement, and energy. The evidence keeps accumulating, the framework keeps getting stronger, and the public conversation about what it means remains almost non-existent. That the Wheeler-DeWitt equation and the Page-Wootters mechanisms are not the only lines of evidence pointing to the unreality of time. There is a much older argument, one that does not depend on quantum gravity at all, that comes from the other pillar of modern physics. Einstein's own theory of relativity, the special theory published in 1905, contains within it a conclusion about the nature of time that Einstein himself accepted and that most physicists today quietly acknowledge, even if they rarely say it out loud. The conclusion is that the future already exists, not the future will exist when it happens. It already exists, right now, in the same way that the past exists, in the same way that distant places exist, even when you are not looking at them. The future is out there, in the 4-dimensional structure of space-time, as real and as fixed as last Tuesday. To understand why, you need to understand one of the strangest features of special relativity, a feature called the relativity of simultaneity. And to understand that, you need to understand what Einstein found when he tried to answer what seemed like a simple question. What does it mean for 2 events to happen at the same time? Before Einstein, the answer seemed obvious. 2 events are simultaneous if they happen at the same moment. There is a universal now that extends across the entire universe, a single slice of time that divides the past from the future, and events either fall on that slice or they do not. Newton assumed this. Everybody assumed this. It seemed self-evident. Einstein showed it was wrong. In special relativity, whether 2 events happen at the same time depends on how you are moving. If you are at rest relative to 2 events, and you determine that they are simultaneous, someone moving relative to you will disagree. They will say, one event happened before the other. And neither of you is wrong. There is no fact of the matter about which events are simultaneous. Simultaneity is not a property of the universe. It is a property of your reference frame. This sounds abstract until you push it to its logical conclusion, which is what the philosophers C. Wim Reitdijk and Hilary Putnam did independently in 1966 and 1967. Reitdijk's paper was titled A Rigorous Proof of Determinism Derived from the Special Theory of Relativity. Putnam's was Time and Physical Geometry. Both arrived at the same conclusion. If simultaneity is relative, then the set of events you call the present is different from the set of events someone else calls the present. Your present includes certain events in the Andromeda galaxy, but someone walking past you on the street in the opposite direction has a different present, one that includes events in Andromeda that are days or even weeks in your future. Those events are in their present right now, and if their present is real, which it must be because there is no privileged reference frame in special relativity, then those future events are real too. They exist, they are as real as the screen you are looking at. Roger Penrose made this vivid in his 1980 book, The Emperor's New Mind, with what is now called the Andromeda Paradox. Two people walk past each other on a street on Earth. One walks toward the Andromeda galaxy, the other walks away from it. They are right next to each other. Their relative velocity is maybe a few miles per hour, walking pace. And yet, because Andromeda is about 2.5 million light-years away, the tiny difference in their velocities translates into a difference in their planes of simultaneity that stretches across days or weeks of time in Andromeda. For the person walking toward Andromeda, an alien fleet has already launched. For the person walking away, the decision to launch has not yet been made. Two realities, separated by weeks, coexisting at the same street corner. This is not a thought experiment about perception. It is not about light travel time or delays in observation. It is about what exists. If both reference frames are equally valid, which special relativity insists they are, then the events that are future for one observer and present for another must both be real. The future is already out there. It has to be, or special relativity is wrong. And special relativity is not wrong. It is one of the most precisely tested theories in the history of science. The philosophical position this leads to is called Eternalism, or the block universe. In the block universe, the past, present, and future all exist with equal reality. Space-time is not a stage on which events unfold. It is a four-dimensional block, a complete static structure containing every event that has ever occurred or ever will occur. There is no flow. There is no passage. The distinction between now and not now is not a feature of physics. It is a feature of consciousness. Albert Einstein knew this. He accepted it. And in one of the most haunting documents in the history of science, he said so. On March 15, 1955, Einstein learned that his closest friend, Michel Angelo Besso, had died. Besso was 81. He and Einstein had known each other since their student days in Zurich. They had worked together at the Swiss Patent Office. Besso was the only person Einstein thanked by name in his 1905 paper on special relativity. The paper that changed everything. They had been friends for over 50 years. Einstein was himself ill. He had only weeks to live. He would die on April 18, 1955, less than a month after Besso. But when he learned of his friend's death, he sat down and wrote a letter to Besso's family. The letter is preserved in the Einstein archives under catalogue number 7245, and it contains a passage that has been quoted more times than almost anything Einstein ever wrote, though rarely with a full understanding of what he meant. Now he has departed from this strange world a little ahead of me. That signifies nothing. For those of us who believe in physics, the distinction between past, present, and future is only a stubbornly persistent illusion. Some people read this as a grieving man offering comfort. That is part of it. But Einstein was not being metaphorical. He was not offering a poetic consolation divorced from his physics. He was stating in plain language the conclusion he had drawn from his own theory of relativity. The distinction between past, present, and future is an illusion. Besso's death was not an ending. In the four-dimensional block of space-time, Besso's entire life, every moment of it, still exists. It has not gone anywhere. It cannot go anywhere. Events in space-time do not vanish. They sit there, embedded in the geometry, as permanent as the geometry itself. Einstein wrote those words on March 21st, 1955. He died 28 days later. In the framework he helped create, his death was not an ending either. And he was not the only one at the Institute for Advanced Study in Princeton thinking about the nature of time. His closest colleague there, the man he walked with almost every day during his final years, was Kurt Godel, the greatest logician since Aristotle. Godel had already shattered the foundations of mathematics with his incompleteness theorems in 1931. Now, at Princeton, he turned his attention to physics. In 1949, he published a paper in the Reviews of Modern Physics, Volume 21, pages 447 through 450, titled An Example of a New Type of Cosmological Solutions of Einstein's Field Equations of Gravitation. The solution described a rotating universe, one in which the matter content of the cosmos spins uniformly. And this rotating universe had a property that should have sent shock waves through physics. It contained closed time-like curves, paths through space-time, that loop back on themselves. A person traveling along such a path would return to their own past. Time travel. Not as science fiction, as a mathematical consequence of Einstein's own equations. Godel presented this solution as a birthday gift to Einstein. Think about that. Two of the greatest minds in human history walking the grounds of the Institute for Advanced Study, and one of them gives the other a mathematical proof that his theory of gravity permits travel backward in time. The gift was not a celebration. It was an argument. Godel believed that if any solution to Einstein's equations permits closed time-like curves, then time, as we normally understand it, the idea that the past is gone and the future has not yet happened, cannot be a fundamental feature of reality. If the equations allow time to loop, then the linear, flowing time of everyday experience is not built into the physics. It is an accident of the particular solution we happen to inhabit. Einstein acknowledged this in his response, published in Albert Einstein, Philosopher-Scientist. He wrote that in a universe containing closed time-like curves, the distinction between earlier and later must be abandoned for world points which lie far apart in a cosmological sense. He did not dismiss Godel's solution. He took it seriously. He called it interesting and suggested that it should be investigated whether such solutions should be excluded on physical grounds, not on mathematical ones. The math was fine. Einstein knew it. Godel knew it. The equations of general relativity do not protect time. Our universe is not a Godel universe. It does not rotate in the way Godel's solution requires. But Godel's point was not about our particular universe. It was about what the laws of physics allow. If the laws allow time to loop, if they allow the distinction between past and future to dissolve, then that distinction was never fundamental to begin with. It was always contingent, always fragile, always, in some deep sense, illusory. Godel died in 1978, Einstein in 1955, DeWitt in 2004. Barbour is still alive, still working from his farmhouse near Banbury, still thinking about the same question that seized him on a train in the Bavarian Alps in 1963. And in the decades since all of these people began pulling on the same thread, from different directions, using different methods, the thread has only gotten stronger. Carlo Rovelli, an Italian theoretical physicist and one of the founders of loop quantum gravity, published The Order of Time in 2018. The book, which was read as an audiobook by Benedict Cumberbatch, became an international bestseller and introduced millions of people to the idea that time is not fundamental. Rovelli's argument draws on his technical work with the French mathematician Alain Connes on what they call the thermal time hypothesis. The idea is that the time we experience is not a fundamental parameter of the universe, but an emergent property, like temperature. Temperature is not a property of individual atoms. It is a statistical property that emerges when you have many atoms and you do not track each one individually. Rovelli argues that time is the same kind of thing. It emerges from our coarse-grained, macroscopic ignorance of the microscopic details of the world. If you could see every quantum degree of freedom in the universe, time would not exist. It is only because you cannot, because you are a macroscopic being embedded in a system with an incomprehensibly large number of degrees of freedom, that you experience the appearance of temporal flow. In the fundamental equations of loop quantum gravity, Rovelli insists there is no time variable. There are events, and there are relationships between events, and those relationships can be described mathematically without any reference to time. The order in the order of time is not a temporal order. It is the order imposed by thermodynamics, by entropy, by the second law. And the second law, Rovelli points out, is the only equation in all of fundamental physics that distinguishes between past and future. Every other equation, every law of quantum mechanics, every equation of general relativity works exactly the same forward and backward. Only entropy has an arrow, and entropy is not fundamental. It is statistical. It is a consequence of our ignorance, which means the arrow of time is a consequence of our ignorance too. So here is where the evidence stands. The Wheeler-DeWitt equation, the closest thing physics has to an equation of quantum gravity, does not contain time. The Page-Wootters mechanism, confirmed experimentally in Turin in 2014, shows that a static entangled state can produce the appearance of time for observers inside the system. Einstein's own theory of special relativity, through the relativity of simultaneity, implies that the future already exists. Godel showed that general relativity permits closed time-like curves, which means the linear flow of time is not built into the laws of physics. And Rovelli, working from loop quantum gravity, argues that the fundamental equations of physics work better without time altogether. Every line of investigation, from quantum gravity to special relativity to thermodynamics to the direct experimental test of the Page-Wootters mechanism, points in the same direction. The version of you sitting here right now and the version of you that has not yet been born are not separated by time. They are features of the same static structure viewed from different internal perspectives within a geometry that does not move. But that raises a question that should bother you, because it bothered every physicist who encountered this evidence. If time does not exist, if the universe is genuinely static, if there is no flow and no passage and no sequence, then why does it feel so overwhelmingly like there is? Why is the experience of time the most vivid, the most immediate, the most impossible to deny feature of your conscious life? You can close your eyes and doubt the existence of the room around you. You can entertain the possibility that the physical world is a simulation. But you cannot, even for a moment, stop experiencing the passage of time. The sense that this moment is happening now, that the previous moment has passed, that the next moment is approaching, is not something you can switch off. It is running constantly beneath every thought, every perception, every memory. If the physicists are right, and time is not a feature of the universe, then it is a feature of you, of your brain, of the particular way your nervous system processes information. And that is exactly what the neuroscience says. Your experience of now has a name in cognitive science. It is called the specious present, a term coined by the psychologist E. R. Clay in the 1880s and developed by William James in the Principles of Psychology in 1890. The specious present is the window of time that your brain treats as the current moment. It is not an instant. It is not infinitely thin the way a mathematical now would be. It has duration. Experiments over the last century have consistently measured it at roughly 2 to 3 seconds. That is the width of your now. Events that fall within this window feel simultaneous, present, happening. Events that fall outside it feel past. Your brain draws the line, and it draws it at about 3 seconds. This is not a metaphor, it is a measured property of your neural architecture, and it means that the boundary between present and past in your experience is not a feature of the external world. It is a processing artifact, a quirk of how your neurons fire. If your brain drew the line at 10 seconds instead of 3, your experience of now would be different. The universe would not change, only your experience of it would. Dean Buonamano, a neuroscientist at UCLA, has spent years studying how the brain constructs the experience of time. In his 2017 book, Your Brain is a Time Machine, he argues that the brain does not detect time the way the eyes detect light or the ears detect sound. There is no time organ. There is no receptor that picks up the flow of moments. Instead, the brain builds the experience of time from scratch, using neural circuits that encode duration, sequence, and the anticipation of future events. Time, in Buonamano's framework, is something the brain manufactures, not something it perceives. And then there is the work of Benjamin Libet, the neuroscientist whose experiments in the 1980s became one of the most discussed and most uncomfortable results in the history of brain science. Libet asked subjects to flex their wrist whenever they felt like it, while monitoring their brain activity. What he found was that the neural activity associated with the decision to move, a signal called the readiness potential, began approximately 550 milliseconds before the person reported consciously deciding to move. Half a second. Your brain starts the action, and then, half a second later, you become aware of deciding to do it. The conscious experience of making a choice lags behind the neural event that initiated the choice by over half a second. The implications of Libet's experiments are still debated, and they should be. The interpretation is genuinely complicated, and reasonable people disagree about what exactly the readiness potential represents. But the raw finding is not in dispute. The timing is real. Conscious awareness of a decision comes after the neural processes that generate it, which means your subjective experience of now, of this being the moment in which things are happening and choices are being made, is retrospective. It is your brain's reconstruction of events that have already occurred at the neural level. You are not experiencing the present, you are experiencing a story your brain is telling you about what just happened. This is where the physics and the neuroscience converge in a way that should unsettle you. Physics says the universe is static. Neuroscience says your experience of time is constructed by your brain. These two findings come from completely different fields, from completely different experimental traditions, from people who are mostly not talking to each other. And yet they point to the same conclusion, the sensation of now, the feeling that this moment is special, that the past is gone and the future has not happened, is not a feature of the universe. It is a feature of you, of the way your brain processes information within a structure that at the fundamental level does not change. You are not moving through time. You have never moved through time. What you're experiencing is a sequence of correlations, a pattern of entanglement between the state of your brain and the states of the things around you. And that pattern exists all at once in the timeless wave functional that solves h psi equals 0. The sensation of flow is what entanglement feels like from the inside. It is the Page-Wootters mechanism running on 86 billion neurons instead of 2 photons. Now, in the interest of being honest with you, because this channel does not tell you what to think, it tells you what the evidence says and lets you sit with it, I need to tell you about the strongest argument against everything I have just described. Because there is one, and it comes from a serious physicist, and ignoring it would be dishonest. Lee Smolin is a theoretical physicist at the Perimeter Institute for Theoretical Physics in Waterloo, Ontario. He is one of the founders of loop quantum gravity, the same approach to quantum gravity that Rovelli works in. He is brilliant, he is provocative, and in 2013 he published a book called Time Reborn, in which he argues against the dominant view among his colleagues that time is real, not emergent, not approximate, not a useful fiction, real, fundamental, the most fundamental thing there is. Smolin's argument is layered, and I am going to give it to you fairly, because it deserves that. His central claim is that the timeless approach to physics, the one endorsed by Barbour, Rovelli, and the Wheeler-DeWitt equation, works well for describing small subsystems of the universe, but fails when applied to the universe as a whole. The problem, Smolin argues, is that the timeless framework always requires an external perspective, a godlike observer who sits outside the system and describes it as a static block. For a laboratory experiment, for Moreva's 2 photons in Turin, that external perspective is available. The experimenters are outside the system. They can measure the global state. But for the universe as a whole, there is no outside. There is nobody standing outside the block looking in. And Smolin argues that this means the block universe picture is incoherent when applied to cosmology. He goes further. He claims that the laws of physics themselves evolve over time, that the constants of nature, the parameters that determine the strengths of forces and the masses of particles, are not fixed eternal truths, but contingent features of a universe that changes. This is a radical proposal, and it remains speculative. Smolin himself acknowledges that the evidence for evolving laws is thin, but the philosophical challenge he poses to the timeless view is genuine. If there is no outside to the universe, then who is the external observer? Who sees the static block? And if nobody sees it, in what sense does it exist? The New York Times reviewer James Glake called Smolin's arguments as provocative, original, and unsettling as any I've read in years. The book is worth reading, and the argument is worth taking seriously. But here is what you should notice about the framing. Smolin wrote Time Reborn because he was fighting against the consensus. He wrote it because the dominant view among theoretical physicists working on quantum gravity is the timeless view. He wrote it because he needed to make a case for time being real, which means the default position, the one he was arguing against, is that time is not real. When Smolin describes his own motivation, he says he used to believe in the unreality of time. He praised Barbour's timeless view in his earlier book, The Life of the Cosmos. He changed his mind partly, he says, because of conversations with his young son, who was awakening to the reality of time passing. That is a beautiful and honest admission, but it is an admission that his position is the minority one. The leading defender of time's reality in theoretical physics wrote an entire book precisely because most of his colleagues disagree with him. That is not an argument against Smolin. Minority positions in science sometimes turn out to be correct. But it tells you something about where the field stands. If the person making the strongest case for time being real frames his own book as a dissenting voice against the prevailing orthodoxy, then the prevailing orthodoxy is the timeless view. And the prevailing orthodoxy has the Wheeler-DeWitt equation, the Moreva experiment, the relativity of simultaneity, the Andromeda Paradox, Godel's rotating universe, and the entire apparatus of thermodynamic time built on the statistical mechanics of entropy working in its favor. The evidence is not perfectly settled. This is an active area of research, and honest physicists disagree. But the weight of the evidence, the direction in which the preponderance of data points, is toward a universe in which time is not fundamental. And the people working at the frontier of this research know it. Which brings me back to the question that has been building since the beginning of this video. The question that everything I have told you has been circling around without quite landing on. If the Wheeler-DeWitt equation is right, if the Page-Wootters mechanism is right, if special relativity is right about the block universe, if Rovelli is right about thermal time, if Barbour is right about Platonia, if the neuroscience is right about the specious present and the constructed nature of temporal experience, if all of these lines of evidence are pointing where they appear to be pointing, then what are you? Not what do you believe about physics? What are you, physically, as an object in a universe that does not change? The answer, if you take the evidence seriously, is that you are a pattern, a static pattern in a frozen geometry. You are a particular arrangement of matter and energy, a specific configuration of particles embedded in a four-dimensional block of space-time that contains every configuration that has ever existed or will ever exist. The version of you that was 5 years old is not gone. It is still there, in the block, at the space-time coordinates where it always was and always will be. The version of you that will exist 10 years from now is not waiting to happen. It is already there. It has always been there. It exists with exactly the same ontological status as the version of you experiencing this moment. And the sensation of now, the feeling that this particular moment is real in a way that last Tuesday is not, is a property of your neural architecture. It is the specious present. It is the 3-second window within which your brain labels experiences as happening. It is not a feature of the universe. The universe does not have a now. Physics does not have a now. Only brains have a now. And brains are physical objects sitting inside the block, made of atoms that obey the same timeless equations as everything else. Let me be precise about what I'm saying, because precision matters here, and vagueness is where the escape routes hide. I am not saying time is a useful concept that breaks down at extreme scales. I am not saying our perception of time is imperfect. I am not saying time is complicated and we do not fully understand it. Those are all true statements, but they are soft statements, and the evidence supports a harder one. The harder statement is this: the most fundamental equation in quantum gravity does not contain a time variable. An experiment in a laboratory in Turin confirmed that a static entangled state produces the appearance of time for internal observers. Einstein's theory of special relativity implies that the future already exists. Godel's solution to Einstein's equations permits time to loop, meaning time's linearity is not fundamental. The only equation in physics that distinguishes past from future is the second law of thermodynamics, and that law is statistical, not fundamental. And the neuroscience of temporal perception shows that the experience of now is a constructed artifact of neural processing, not a detection of an external reality. Each of these facts is individually well established. Together they form a picture that most physicists accept privately and almost none will state plainly in public. The universe does not change. Everything exists at once. Your experience of time passing is something your brain generates, not something the universe provides. The Wheeler-DeWitt equation was published in 1967. The Page-Wootters mechanism was proposed in 1983. The Andromeda Paradox was published in 1989. Barbour's The End of Time came out in 1999. The Moreva experiment was published in 2014. Rovelli's The Order of Time came out in 2018. This evidence has been accumulating for over 50 years, half a century of physics, from quantum gravity to special relativity to laboratory experiments to neuroscience, all converging on the same conclusion. And yet if you stopped a random physicist at a cocktail party and asked, Does time exist? The most common answer you would get is an uncomfortable pause, followed by something like, well, it depends on what you mean by exist. That is not an answer. That is a dodge. And the reason they dodge is not that the evidence is unclear. It is that the evidence points somewhere they do not want to go in a conversation with a stranger holding a glass of wine, because the place the evidence points is not a comfortable place. It is the place where you realize that you have never been moving, that the flow of your life from birth to death is not a journey. It is a shape, a static shape in a frozen block, and every point of that shape exists with the same permanence as every other point, and the feeling that you are here, now, reading this, while other moments have passed and other moments are yet to come, is a story your brain tells itself. A very convincing story, a story so compelling that you cannot stop believing it even after the evidence shows it is not real. A stubbornly persistent illusion, as Einstein put it. Stubbornly persistent. He chose those words carefully. He knew you would not be able to let go of it. He could not let go of it either. Nobody can. The illusion is built into the hardware. It is what brains do. But here is what none of that explains. None of it tells you why the illusion feels this way. Why it feels like a forward motion rather than a backward one. Why it feels like you are heading from birth to death and not the other direction. The block universe by itself does not explain the arrow. It tells you that the block exists, that past and future are equally real, but it does not explain why your experience of the block has a direction. And this is where the last piece of the puzzle comes in, the piece that connects everything, the one that takes what you have already heard and makes it worse, because the arrow of time, the direction, the reason you remember yesterday but not tomorrow, is not a property of the block. It is not a property of space-time. It is not written into the Wheeler-DeWitt equation. It is not even a property of your brain in some general sense. The arrow of time is a property of one specific physical fact about the universe, a fact that physicists have been trying to explain for over a century, and that, as of this moment, has no fundamental explanation at all. That fact is the initial condition of the universe, the state of extraordinarily low entropy at the Big Bang. The second law of thermodynamics says entropy increases. Things go from ordered to disordered. Eggs break and do not unbreak. Coffee cools and does not spontaneously reheat. This is the arrow. This is the direction. But the second law only works because the universe started in a state of absurdly low entropy. If it had started in a high entropy state, there would be no arrow. There would be no direction. The block would still exist, but you would not experience it as a story moving forward. You would not experience it at all, because in a high entropy universe, there are no complex structures, no brains, no observers. Everything you experience is the passage of time. Every memory, every anticipation, every heartbeat reduces to one fact. The universe started in a special state, and we do not know why. That is not a figure of speech. There is no accepted explanation in physics for why the initial entropy of the universe was so low. Roger Penrose has estimated the probability of the initial state occurring by chance at 1 in 10 to the power of 10 to the power of 123. That number is so large that writing it out in decimal notation would require more digits than there are particles in the observable universe. It is, for all practical purposes, impossible. And yet it happened. Or rather, it is, because in the block universe, the Big Bang did not happen in the past. It exists. It is a region of the block, and the extraordinary specialness of that region, the absurd precision of its low entropy, is the sole reason you experience the block as a story, with a direction. Barbour has his own interpretation of this. He does not call it the Big Bang in the conventional sense. In his framework, the low entropy configuration is a special place in Platonia, a region he calls alpha. Alpha is not the beginning of time. There is no beginning of time because there is no time. Alpha is a particular kind of now, a configuration with a very specific mathematical property. It is a point of minimal complexity from which many different paths of increasing complexity radiate outward. The arrow is not temporal, it is structural. It is the fact that configurations near alpha naturally give rise to records, to structures that contain evidence of other configurations. And those records are what brains interpret as memories of a past. That is an extraordinary claim. And it brings us back to where we started, to the equation that Bryce DeWitt published in 1967, the equation that John Wheeler asked him to write, the equation that erased time from the fundamental description of reality. Because the thing that makes Barbour's claim extraordinary is that it is consistent with the Wheeler-DeWitt equation. It is consistent with the Page-Wootters mechanism. It is consistent with the Moreva experiment. It is consistent with Rovelli's thermal time. It is consistent with the block universe. It is consistent with the neuroscience of temporal perception. Every line of evidence that we have examined points in the same direction, and the direction is toward a universe that does not change, has never changed. Because change requires time, and time is not in the equation. And what that means for you, for what you are, for what death is, for what memory is, for whether anything you do matters in a universe where everything has already been done, is the part that physicists will not say on camera. But I am going to say it, because you clicked on this video, and that means you want to know. And the thing about wanting to know is that you cannot unknow it afterward. You are asking what happens to the concept of death in a universe where time does not exist. You are asking what happens to free will if the future already exists. You are asking what you are as a conscious being in a frozen geometry where nothing has ever changed. These are not philosophical questions. They are physical ones, and the answers the physics provides are not comfortable. Start with death, because that is the one everyone wants to know about, even if they will not say so. If the block universe is real, if eternalism is correct, if the Wheeler-DeWitt equation is describing something true about reality, then death is not what you think it is. In the ordinary picture, the one you grew up with, death is an ending. You exist for some number of years, and then you stop existing. The matter that made up your body disperses. Your consciousness ceases. The lights go out. There is a before in which you were here, and an after in which you are not. Death is the boundary between those two regions. It is the moment when your timeline stops, but in the block universe, there is no moment when your timeline stops. Your timeline does not stop because it was never moving. It is a shape, a four-dimensional shape, a world line, embedded in the block of space-time. It has a beginning and an end, in the sense that it has two endpoints in the block, roughly corresponding to what you would call birth and death. But those endpoints are not events that happen. They are features of the geometry. They exist with the same permanence as every other point on your world line. The point at which you were born is still there. The point at which you will die is already there. And every point in between, every moment of your life, is there too, simultaneously, permanently, not flowing, not fading, not approaching, just there. Einstein understood this. It is why he wrote what he wrote to Besso's family. Now he has departed from this strange world, a little ahead of me. That signifies nothing. Think about the weight of that sentence. That signifies nothing. Not that is a great loss. Not he will be missed. That signifies nothing. Because in the physics Einstein devoted his life to, Besso's death was not a departure from existence. It was a feature of Besso's world line, a geometric property of his four-dimensional shape in the block. Besso, at age 20, sitting in a Zurich cafe arguing with Einstein about electrodynamics, still exists. He has not gone anywhere. He cannot go anywhere. Events in space-time do not move. and Einstein knew that the same was true of himself. Less than a month later, on April 18th, 1955, Einstein died of an abdominal aortic aneurysm at Princeton Hospital. In the block universe, that event is not an ending, it is a boundary. Einstein's worldline has a specific shape, extending from March 14th, 1879 in Ulm, Germany, to April 18th, 1955 in Princeton, New Jersey. The entire shape exists. The young Einstein riding a beam of light in his imagination is as real as the old Einstein writing condolence letters from his sickbed. Neither moment is more present than the other, neither has passed, neither is yet to come. This is either the most terrifying or the most comforting implication in the history of physics, depending on what you do with it. And the fact that physicists cannot agree on which one it is tells you something about how deeply this cuts. But notice what you have to give up to accept this comfort, if comfort is what it is. You have to give up the idea that you are going somewhere. You have to give up the idea that the future is open. You have to give up the idea that the choices you make right now are determining what happens next, because next is not a real concept. There is no next. There is just the block, and your world line, whatever shape it has, already has that shape. Every decision you will ever make has already been made, not in the sense that it was made in the past and is now fixed, but in the sense that it exists in the block alongside every other event, with no temporal priority, no sequence, no flow from undecided to decided. And that is where most people start to feel the ground shift beneath them. Because free will, the sense that you could have done otherwise, that the future is genuinely open and your choices genuinely determine what happens, is not just a belief, it is the foundation of your entire experience of agency. Every morning you wake up and face what feels like a branching tree of possibilities. You choose this, not that. You go left, not right. The feeling of choosing is so vivid, so constant, so deeply woven into your experience, that questioning it feels like questioning whether you are conscious at all. The block universe does not exactly eliminate free will. Philosophers have been arguing about this for decades, and the positions are genuinely complex. There is a school of thought called compatibilism that argues free will and determinism are not in conflict. That free will refers not to some metaphysical power to override the laws of physics, but to the everyday experience of acting on your desires without external coercion, and that this kind of freedom is perfectly compatible with a block universe. Daniel Dennett, the philosopher, has argued this position with considerable force, and there are physicists who agree. But there is something deeply unsatisfying about compatibilism in the context of what we are discussing here. Because the question is not whether you are free in some philosophical sense. The question is whether the future is open, whether the decision you are about to make has not yet been made. And in the block universe, the answer to that question is no. The decision exists, it has always existed, it will always exist. The sensation that you are deliberating, that the outcome is uncertain, that you could go either way, is real as an experience. But it is not a description of the underlying physics. The underlying physics is a static block in which your entire world line, including every decision you will ever make, is already laid out. Smolin hates this. It is one of the reasons he wrote Time Reborn. He believes that the openness of the future is real, that novelty is real, that the decisions you make are genuinely creative acts that bring new events into existence. And his position deserves respect. But again, notice the framing. Smolin is arguing against the dominant view. He is fighting for the reality of an open future, because the physics, as most of his colleagues interpret it, points toward a closed one. So, let me ask you something directly, because you have been listening for a long time now, and you deserve to be addressed as an adult. Does any of this change anything? If the block universe is real and the future already exists, does that change what you do tomorrow morning? Does it change whether you get out of bed? The honest answer is no, And the reason it does not change anything is itself part of the physics. You cannot experience your local slice of it, your specious present, your 3-second window of now. The block exists, but you are trapped inside it, perceiving one thin cross-section at a time, unable to see the rest of the structure from the inside. The Page-Wootters mechanism explains exactly why. You are an internal observer, correlated with your own clock, and from the inside, time appears to pass. The fact that it does not pass, the fact that the global state is static, is invisible to you. It is invisible by construction. It is invisible because the mechanism that generates the appearance of time is the same mechanism that hides the timelessness of the whole. This is the paradox at the heart of the entire discussion. The evidence that time does not exist is overwhelming, but the evidence is only accessible to beings who experience time. The Moreva experiment was conducted by physicists who planned it in advance, executed it over a period of weeks or months, and published the results afterward. Every step of the process that revealed the timelessness of the global state was itself conducted within the apparent flow of time. The experiment that proves time is an illusion was performed in time. And this is not a contradiction. It is the Page-Wootters mechanism working exactly as predicted. Internal observers experience time. They do science within that experience. And the science they do reveals that the experience is generated by entanglement, not by a fundamental flow. You are inside the illusion, and the illusion is perfect. That is not a flaw, that is the design. Or rather, it is not a design at all, because there is no designer. It is a mathematical consequence of the way entanglement works when applied to a system that satisfies the Wheeler-DeWitt equation. The illusion of time is what entanglement looks like from the inside of a static universe. It is not optional. It is not something you can see through by trying hard enough or meditating deeply enough or understanding enough physics. It is structural. It is built into the mathematics of the situation. You will experience time passing for as long as your world line contains a functioning brain, and no amount of knowledge about the block universe will change that experience. And yet, knowing it changes something, not the experience, but the interpretation. Not what you feel, but what you understand about what you feel. And that is a different kind of change, one that is harder to pin down but no less real. Consider memory. In the ordinary picture, memory is a causal process. Something happens to you. Your brain encodes it. Later, your brain retrieves the encoding, and you remember. The memory is caused by the event comes first, the memory comes second, and the causal chain flows forward in time from event to encoding to retrieval. In Barbour's framework, that causal chain does not exist. Each frozen configuration of the universe contains within it certain structures. Some of those structures are brains. Some of those brains contain patterns that function as records of other configurations. But the records are not caused by the other configurations in any temporal sense. They are properties of this now, features of this particular arrangement of matter. The now that contains your memory of breakfast is not connected to an earlier now in which you were eating breakfast by any flow of time. Both nows exist in Platonia. Both are equally real, and the memory in your brain is not a recording of something that happened. It is a structural feature of the configuration you currently occupy. This is the part that most people find the hardest to accept, harder even than the block universe, harder than the death of free will. Because memories feel so obviously causal, you remember things because they happen to you. The idea that the memory and the event are two separate, equally real, temporally unconnected configurations that happen to share a structural relationship is so alien to everyday experience that it feels like nonsense. But consider what the neuroscience actually says about memory. Memory is not a recording. That much has been established beyond any serious dispute. When you remember something, you are not playing back a tape. You are reconstructing. Every act of remembering is an act of creation. Your brain takes fragments, cues, emotional residues, and builds a narrative that feels like a faithful reproduction, but is, in reality, a confabulation. A story your brain tells itself based on the materials available in the current moment. Memories change every time you access them. They are contaminated by your current emotional state, by information you acquired after the event, by the simple act of retrieval itself. The memory of your 10th birthday that you carry with you today is not the memory you formed at age 10. It is a reconstruction, rebuilt from scratch every time you think of it, shaped by who you are now rather than who you were then. If memory is reconstruction rather than retrieval, if the act of remembering is a present tense construction rather than a past tense playback, then the distinction between Barbour's picture and the ordinary picture becomes less stark than it initially appears. In both pictures, what you have in the present moment is a brain containing certain structures. In the ordinary picture, those structures are causally descended from earlier events. In Barbour's picture, those structures are properties of the current configuration that happen to correlate with other configurations in Platonia. The subjective experience is identical. The only difference is the metaphysical story you tell about why the structures are there. And the metaphysical story that requires time, that requires a causal flow from past to present, is the one that the Wheeler-DeWitt equation does not support. The equation does not contain time. It does not contain causation in the temporal sense. It contains the wave functional of the universe, defined over the space of all possible configurations. And it says that functional is static. Whatever story you want to tell about why your brain contains the patterns it contains, the story cannot invoke the passage of time, because the most fundamental equation in quantum gravity says time does not pass. Let me bring this back to something concrete, because the danger with this kind of discussion is that it floats off into abstraction and loses its weight. So think about a specific moment. Think about someone you love. Think about the last time you saw them. Think about the details, what they were wearing, what they said, how the light fell. Hold that in your mind. In the ordinary picture of time, that moment is gone. It happened, and now it has passed. It exists only in your memory, and your memory, as we have established, is an unreliable reconstruction that degrades every time you access it. The moment itself has vanished. It is nowhere. It no longer exists. The atoms that were arranged in that pattern have scattered, and the pattern is lost forever, except as a fading echo in the neural connections of your brain. In the block universe, that moment is not gone. It exists. It still exists. It will always exist. It is a specific point in the four-dimensional structure of space-time, a particular arrangement of matter and energy at a particular set of coordinates, and it is there right now, not in the past, not back then, there. The light that fell on the person you love in that moment is still falling. The words they said are still being said. The expression on their face is still there, embedded in the geometry of the block, as permanent as the geometry itself. That is what Einstein was trying to tell Besso's family. Besso was not gone. He was not nowhere. He was right there, at his coordinates in the block, living every moment of his life with the same permanence as the moment in which Einstein was writing the letter. The separation between the living and the dead is not a gap. It is a distance. A distance in the block are not separations in the way we normally mean. Everything in the block is equally present. The dead and the living and the unborn, all coexisting in a structure that does not move. Whether you find this beautiful or horrifying depends on something about you that I cannot predict. Some people hear this and feel a profound relief. The people they have lost are not gone. They are right there, permanent, unchanging, safe inside the geometry of space-time. Others hear this and feel a new kind of grief, because the people they have lost are right there, and they cannot reach them. The block contains everything, but you are trapped in your slice of it, experiencing one thin moment at a time, unable to look back and see the people you miss still living their lives at their coordinates. Both reactions are valid. Both are rational responses to the same information. And neither changes the physics. There is something else that should bother you about this, something beyond the personal implications. And it is the silence. Because think about what we have just described. Think about the weight of the claim and the weight of the evidence supporting it. The most fundamental equation in quantum gravity says the universe is static. A laboratory experiment confirmed the mechanism by which a static universe produces the appearance of time. Special relativity implies the future already exists. General relativity permits time to loop. The only physics that gives time a direction is entropy, and entropy is a statistical artifact of incomplete knowledge. The neuroscience says your experience of now is constructed, not detected. Every one of those claims is supported by published, peer-reviewed research. Everyone has been checked and rechecked by the relevant scientific community. And the combined implication that you are a static pattern in a frozen geometry and the flow of your life is not real is arguably the most consequential scientific finding in human history. More consequential than heliocentrism, which merely changed where you are. More consequential than evolution, which changed where you came from. More consequential than quantum mechanics, which changed what matter is. Because this changes what time is, and time is not one feature of your experience among many. Time is the medium of your experience. It is the river in which everything else floats. And the finding is that the river does not flow. This should be on the front page of every newspaper on Earth. It should be taught in every physics class. It should be the subject of public debates and congressional hearings and late-night conversations between people who are terrified and exhilarated in equal measure. It is not. It is in seminar rooms. It is in arXiv preprints. It is in books by Barbour and Rovelli that sell respectably but never crack the public consciousness the way they should. And the question you should be asking is why. Part of the answer is technical difficulty. The Wheeler-DeWitt equation is hard to explain. Canonical quantization of the gravitational field is not the kind of thing that fits in a headline. The Page-Wootters mechanism requires an understanding of quantum entanglement that most people do not have. The Andromeda Paradox requires comfort with the relativity of simultaneity. These are not ideas you can reduce to a tweet. But that is not the whole answer, and you know it. The whole answer is that the implication is too threatening, not to any political faction, not to any economic interest, not to any religious institution, though it certainly conflicts with most religious accounts of time and creation and the soul. The implication is threatening to something more basic than any of those things. It is threatening to the operating system of the human mind. The experience of time is not an opinion you hold. It is not a belief you can revise. It is the foundation of your phenomenal experience, the substrate on which every other experience is built. Telling someone that time does not exist is not like telling them that the Earth is not flat or that species evolve. Those revisions to common sense are uncomfortable but survivable. They change what you think about the world without changing what it feels like to be in the world. The dissolution of time changes what it feels like to be in the world, or at least it should if you take it seriously. And most people, including most physicists, do not want to take it that seriously. There is a phenomenon in the philosophy of science called a Kuhnian crisis, named after Thomas Kuhn and his 1962 book, The Structure of Scientific Revolutions. A Kuhnian crisis occurs when the dominant paradigm in a scientific field accumulates enough anomalies that it can no longer function as a coherent framework, but no new paradigm has emerged to replace it. The field enters a period of confusion, debate, and often denial, in which practitioners continue working within the old paradigm while acknowledging privately that it no longer holds. The problem of time in quantum gravity is a Kuhnian crisis. The old paradigm that time is a fundamental feature of reality, an external parameter in which events unfold, has been contradicted by the most fundamental equation in the field. The new paradigm, that time is emergent and the universe is static, has substantial theoretical and experimental support, but no complete mathematical framework. And the field is stuck between them, unable to go back and unwilling to fully go forward. Physicists continue to use time as a parameter in their calculations because the calculations work, even though they know the parameter they are using does not appear in the fundamental equation. They treat time as a useful fiction, the way a cartographer uses a flat map to represent a curved Earth. The map works for local navigation, but the Earth is not flat, and the universe is not temporal. I want to be careful here because the fault lines channel does not traffic in conspiracy theories, and I am not going to start now. Nobody is suppressing this information. Nobody is running a cover-up. The papers are published. The books are available. The Moreva experiment is freely accessible on the archive. Anybody with an internet connection and a willingness to read can find everything I have told you tonight and verify it for themselves. The silence is not a conspiracy. It is something more insidious than a conspiracy. It is a collective failure of nerve, a quiet, uncoordinated agreement among thousands of intelligent people that this particular implication of this particular equation is too uncomfortable to talk about in public, and that the best strategy is to work on the technical problems and hope the philosophical implications take care of themselves. They have not taken care of themselves. They have been sitting there, unaddressed, since 1967. But there is a deeper implication, one that goes beyond death and memory and free will, one that the script has been building towards since the first paragraph, and it is this. If the Wheeler-DeWitt equation is correct, if the universe is described by a static wave functional, if time is an emergent property of entanglement, rather than a fundamental feature of reality, then the question, what are you, has an answer that no version of this question has ever had before in the history of human thought. You are not a thing that persists through time. You are not a continuous entity that exists at one moment and then exists at the next moment and accumulates a history as it goes. You are not something that was born and will die, with a life in between. Those descriptions all require time, and time is not in the equation. What you are, according to the physics, is a pattern, a static, four-dimensional pattern in a geometry that does not change. You have spatial extent, the space your body occupies. You have temporal extent, the duration of your world line from birth to death. But temporal extent does not mean you extend through time the way a rope extends through space. It means you are a shape in the block, a shape that includes, at one end, the configuration of matter that you would call being born, and at the other end, the configuration that you would call dying. And the shape does not move. The shape does not experience. The shape does not feel the passage of time. The shape is just there. Think about what that means for the question, who are you? In the ordinary picture, the answer is something like a person who persists through time, accumulating experiences, changing, growing, aging. You are a narrative, a character in your own story, and the story has a direction. It begins at birth, it ends at death, and between those 2 points you make decisions and have experiences and become who you are. In the block universe, there is no narrative. There is no character. There is no becoming. There is only the shape, and the shape does not become anything. It is. Every point along the shape is equally real, equally present, equally you. The version of you at age 5, terrified of the dark, is not a former you. It is a current you, at different coordinates in the block. The version of you at age 80, if you live that long, is not a future you. It is a current you. at different coordinates. All of them are you simultaneously, permanently, and none of them is the real you, and none of them is the past or future you. The idea that you are one specific version of yourself, the one sitting here right now, experiencing this moment, is the specious present talking. It is your 3-second window imposing a false privilege on one particular cross-section of the shape, declaring that this cross-section is now, and all others are then. But the block does not agree. The block has no now. The block has no opinions about which cross-section of your shape is special. Every cross-section generates its own specious present, its own feeling of immediacy, its own conviction that it is the real now. And all of those specious presents are equally real and equally illusory, each one a local artifact of a brain doing what brains do inside an entangled system. The experience of being you, the feeling of sitting here, the sense that this moment is happening now, is not a property of the shape as a whole. It is a property of a particular cross-section of the shape. Your brain at this particular point along your world line contains a specious present of approximately 3 seconds, within which experiences feel current. That specious present is a feature of this cross-section. The cross-section at a different point along your world line has its own specious present, its own now, its own feeling of immediacy. And both cross-sections exist simultaneously in the block. The you of 10 years ago and the you of right now are both experiencing their respective nows with equal vividness, equal immediacy, equal conviction that they are the ones living in the present. Neither of you is more real than the other. Neither of you is the current version. There is no current version. There is only the shape, and the shape has many cross-sections, and each cross-section feels like now to the brain it contains. This is the Page-Wootters mechanism applied to a brain instead of a photon. Your brain is entangled with the rest of the universe. The correlations between the state of your brain and the state of the things around you create the appearance of a sequence, a flow, a timeline. But the appearance is generated by entanglement, not by the passage of time. And the global state, the state of the whole system, you and the universe together, does not change. H psi equals 0. Bryce DeWitt spent 57 years of his life working on the equation that says this. He started his PhD in 1947. A 24-year-old kid at Harvard who had decided to quantize gravity, and he worked on it until he died of pancreatic cancer on September 23, 2004, at his home in Austin, Texas. He was 81 years old. His wife Cecile, his intellectual partner for over half a century, survived him by 13 years, dying in 2017 at the age of 95. They are buried together in France, the country of her birth. There is something about DeWitt's story that I have not told you, and I saved it for now because it belongs here, at the end, where you can feel its weight. When DeWitt was a young man at the Institute for Advanced Study in 1949, he visited the great Wolfgang Pauli in Zurich. He told Pauli he wanted to quantize gravity. Pauli paused, rocked back and forth and said, "That is a very important problem, but it will take somebody really smart." DeWitt was not deterred. He spent the next 57 years proving that he was somebody smart enough. He produced not just the Wheeler-DeWitt equation, but a vast body of work on the quantization of gauge theories, on Feynman path integrals applied to gravity, on the Everett many worlds interpretation, on the mathematical foundations of quantum field theory in curved space-time. He was, by the admission of people who knew his work, one of the most important physicists of the second half of the 20th century. And yet, he is not famous, not in the way Einstein is famous, or Feynman, or Hawking. His name does not appear in popular science books except as a label attached to an equation that the popular science books rarely explain correctly. When he died in 2004, the obituaries in the major newspapers were brief or non-existent. Physics Today published a proper memorial, written by his colleagues, which described him as arguably the most underappreciated scientific leader of the late 20th century. They were being generous. He was not arguably the most underappreciated. He was, without qualification, the most underappreciated. He wrote the equation that should have changed humanity's understanding of itself, and humanity barely noticed. He received the Dirac Medal in 1987, the Marcel Grossman Award in 2000 jointly with Cecile, and the American Physical Society's Einstein Prize in 2005, awarded posthumously. The physics community honored him after he was gone. They gave the awards, they named the equation, but they never fully reckoned with what the equation says. Consider what it meant for DeWitt personally. He spent his entire adult life working on an equation that says the universe does not change. Every morning he woke up, experienced the passage of time, drank his coffee, sat at his desk, and worked on the mathematics of a universe in which none of those actions were unfolding in sequence. The equation he was writing said that the act of writing it was not happening in any temporal sense. The career he was building was not a progression from young physicist to old physicist. It was a static shape in a block. The daughters he was raising were not growing up. They were four-dimensional shapes whose cross-sections at certain coordinates happened to be smaller than their cross-sections at other coordinates. He lived inside the illusion for 81 years while writing the equation that proves the illusion is an illusion. And he never, as far as I can tell from his published work and from the accounts of people who knew him, showed any sign of existential crisis about it. He simply did the math. He followed the equations where they led. He did not flinch, and when the equations led to a universe without time, he published the result and moved on to the next calculation. There is something admirable about that, and something almost inhuman. But you are not Bryce DeWitt. You do not have the luxury of treating this as a mathematical result and moving on to the next calculation, because the equation is not about abstract space-time geometries. It is about you, about your life, about every moment you have lived and every moment you think you are going to live. And the equation says those moments are not happening, they are not unfolding, they are not coming into being and then passing away. They are all there, fixed, permanent, embedded in a geometry that does not move. And what that means for you, for what you are, for what death is, for what memory is, for whether anything you do matters in a universe where everything has already been done, is the thing that DeWitt's equation has been saying since 1967, and that the physics community has been studiously not saying in public ever since. Barbour, still working from his farmhouse outside Banbury, has been saying it for decades. We have no direct evidence of the past. We have memories, and memories are present-tense structures in present-tense brains. We have fossils, and fossils are present-tense objects in present-tense rocks. We have light from distant galaxies, and that light is arriving in the present. Everything we use to construct the idea of a past is available in the now. The past is a story we tell based on current evidence. It is a very convincing story, but it is not the same thing as a past that actually happened in a temporal sense, causally connected to the present through a flow of time that the fundamental equation of physics does not contain. This is not a fringe position. Barbour has been saying this for over 40 years, and the physics community's response has not been to refute him, but to ignore him. His mathematical framework, developed in collaboration with Bruno Bertotti and later extended on his own, derives the equations of general relativity and quantum mechanics from a timeless starting point using a procedure he calls best matching. The derivation works. The equations come out correctly. Nobody has shown that the derivation is wrong. The physics community's objection to Barbour is not that his math is incorrect, but that his interpretation is too radical. They would rather live with the problem of time as an unsolved technical challenge than accept Barbour's solution, which is that there is no problem because there is no time. In 2009, the Foundational Questions Institute, FQII, an organization that funds research into the foundations of physics, held an essay contest on the nature of time. Barbour submitted an essay titled On the Nature of Time. It won first prize. The judges, all professional physicists, read his argument that time does not exist and awarded it the top prize. And then the broader physics community continued not talking about it. You should find that remarkable. Not because it proves Barbour is right. Essay prizes do not settle physics, but because it demonstrates something about the relationship between what physicists think and what physicists say. The judges who awarded the prize understood the argument. They found it compelling enough to rank it above all other submissions. And yet the conclusion of the argument, that time does not exist, remains something that mainstream physics treats as an eccentricity rather than a serious possibility. The gap between what is acknowledged in private and what is said in public is the scandal, not a scandal of suppression, a scandal of silence, a scandal of polite disengagement from the most disturbing conclusion in the history of their field. Rovelli, in The Order of Time, arrived at a similar place from a different direction. For Rovelli, the dissolution of time is not a tragedy, but a revelation. He compares it to the dissolution of the celestial spheres in the Copernican revolution. When Copernicus showed that the Earth orbits the Sun, the crystalline spheres that had been imagined to carry the planets vanished. They were never there, but nothing was lost. The planets did not disappear, they kept moving. The sky did not fall. What disappeared was a scaffolding that had been mistakenly believed to be real. Rovelli sees time the same way. Time is the scaffolding. It was never part of the structure. Removing it does not make the universe disappear. It makes the universe clearer. But Rovelli is gentler than the evidence warrants, because the Copernican revolution did not change what it means to be human. Learning that the Earth orbits the Sun did not alter the nature of death, or the status of memory, or the question of whether your choices matter. The dissolution of time does all of those things. It restructures the foundations of your existence. It tells you that the person you were yesterday is not a former version of you who has been replaced. It tells you that person is still there, living that day, with no awareness that you are here living this one. It tells you that the person you will be 10 years from now is already there too, has always been there, experiencing their own now at their own coordinates in the block. And it tells you something about the universe itself that is perhaps the most difficult thing of all to absorb. The universe does not happen, it does not unfold, it does not progress. It does not move toward anything or away from anything. It has no trajectory, no development, no story. It is. That is the entire description. The wave functional is static. hc equals 0. The universe is a mathematical object that exists, complete and unchanging, and the sense that something is happening inside it is a local effect produced by entanglement. The physicists know this. The equation has been published for over 50 years. The experimental evidence has been accumulating for over a decade. The philosophical arguments have been refined for over a century, and still, the conversation about what it means happens in seminar rooms and specialized journals and books written by people brave enough or eccentric enough to say it plainly. It does not happen on the evening news. It does not happen in high school physics classes. It does not happen in the public discourse about who we are and what kind of universe we live in. And I think the reason it does not happen is not that people could not understand it. You have understood it. You have been listening for 2 hours and you have followed every step. The reason it does not happen is that the conclusion is too large. It is too fundamental. It rearranges too many things at once. It touches death and free will and memory and identity and the nature of consciousness and the status of the past and the openness of the future and it touches all of them at the same time. And it says the same thing about all of them. The thing you thought was real is not fundamental. The flow is not there. The passage is not there. The distinction between past and present and future is, as Einstein wrote with less than a month to live, a stubbornly persistent illusion. There is one more thing I need to tell you, and it is the thing that bothers me most about all of this. Not the implication for death, or free will, or the status of memory. Those are large implications, but they are in some sense manageable because they apply to individual human lives and individual human concerns. The thing that bothers me most is what this says about the universe as a whole. Because think about what the Wheeler-DeWitt equation is actually describing. It is not describing a universe that was created at some point and then evolved over time into its current state. It is not describing a universe that started with a big bang and expanded and cooled and formed galaxies and stars and planets and eventually produced you. Those descriptions all use time, and the equation does not contain time. What the equation describes is a single mathematical object, the wave functional psi, defined over the space of all possible three-dimensional geometries of the universe, and that object is static. It does not change. It was not created. It will not end. It is not going anywhere. It is not coming from anywhere. It simply is. The Big Bang in this picture is not an event that happened 13.8 billion years ago. It is a region of the wave functional, a particular set of configurations in which matter is extremely hot and extremely dense and extremely uniform. And the heat death of the universe, the eventual state in which entropy has been maximized and nothing interesting happens anymore, is also a region of the wave functional, a different set of configurations. Both regions are equally present in psi. Neither is earlier or later than the other. The wave functional does not care about the arrow of entropy. It contains all configurations, the low entropy ones and the high entropy ones, and everything in between, and it treats them all with perfect democratic indifference. This means the universe was not created, not by God, not by a quantum fluctuation, not by anything, because creation is a temporal concept and the equation does not contain time. The universe did not come into being, it did not emerge from nothing, it did not pop out of a vacuum. Those are all stories that require a before, and there is no before. The wave functional that describes the universe is not the output of a process, it is not the result of anything. It is a static mathematical object that exists, and the question, why does it exist rather than not, is one of the few questions that the framework genuinely cannot answer. Not because the answer is unknown, but because the question assumes a temporal logic, a sequence from non-existence to existence, that the equation does not support. This is where some people reach for God, and I understand the impulse. The existence of a timeless mathematical object that contains all of reality is on its face precisely the kind of thing that religious traditions have been describing for millennia. The block universe looks suspiciously like eternity in the theological sense. The idea that all moments exist simultaneously, that past and future are equally real, that death is not an ending, but a boundary in a structure that persists. These are not far from what mystics have been claiming for thousands of years. Augustine of Hippo, writing in the 5th century, argued that God exists outside of time and perceives all moments at once. The block universe could be read as a secular confirmation of that intuition. But I want to be precise about what the physics does and does not say, because the temptation to smuggle in metaphysical comfort through the back door is strong, and this channel does not do that. The Wheeler-DeWitt equation does not say the universe was designed. It does not say the block was created by a mind. It does not say the timelessness of reality has any spiritual significance. It says h psi equals 0. It says the wave functional is static. It says the math does not contain time. You can interpret that any way you want. But the equation itself is silent on the question of meaning. It tells you what the universe is. It does not tell you what the universe is for, and the difference between those two questions is the difference between physics and everything else. You might think this is where the argument runs out of road. You might think that the inability to answer, "Why does anything exist?" is a fatal weakness. But consider the alternative. In the ordinary picture, the one with time, the question is equally unanswerable. Why was there a Big Bang? What caused the initial singularity? What happened before the beginning? These questions have no answers in conventional cosmology either. The ordinary picture does not solve the mystery of existence. It just frames the mystery differently, using temporal language instead of timeless language. The mystery remains. The only thing that changes is the grammar, and the timeless grammar has one advantage that the temporal grammar does not. It is consistent with the equations. The Wheeler-DeWitt equation says HCI equals 0. It says the wave functional is static. It says there is no time. You can accept this and live with the mystery of why the wave functional exists, or you can reject it and live with the mystery of why the Big Bang happened. Either way, you end up with an unanswerable question. But the first option has the backing of the most fundamental equation in quantum gravity, and the second option requires you to ignore that equation. The physics community, by and large, has chosen to ignore it. Not explicitly, not by publishing papers that say the Wheeler-DeWitt equation is wrong. Nobody says that, because nobody can show it. The equation follows from the standard rules of quantization applied to general relativity. If you accept quantum mechanics and you accept general relativity, the equation is what you get. And everybody accepts both of those things. But they ignore the implication. They work around it. They use time as a parameter in their calculations, while acknowledging in footnotes and review articles that the fundamental equation does not contain it. They solve the Schrödinger equation, which depends on time, while knowing that the Schrödinger equation is an approximation to the Wheeler-DeWitt equation, which does not. Here is how deep the avoidance runs. The language physicists use reveals the psychology. They say, the problem of time, as if it were a bug to be fixed, a technical obstacle to be overcome on the way to a complete theory of quantum gravity. The phrasing implies that the absence of time from the equation is a failure, an artifact that will be corrected when we have better mathematics or a more complete theory. But there is no reason to believe this. The absence of time is not a failure of the equation. It is the equation's most important result. Calling it the problem of time is like calling the Copernican revolution the problem of the Earth's motion. It is not a problem to be solved. It is the answer. And the answer is that time does not exist at the fundamental level. The quantum gravity people say the philosophical implications are outside their expertise. The philosophers say the technical details are outside their expertise. The neuroscientists say the question of fundamental time is outside their domain. And so the most consequential implication of the most fundamental equation in theoretical physics sits in a no man's land between disciplines, acknowledged by all, owned by none, discussed by almost nobody in language that a non-specialist could understand. Even Sean Carroll, a physicist who has done more than almost anyone to bring modern physics to a public audience, has been notably cautious on this question. He has written extensively about the arrow of time and the block universe. He has acknowledged that the block universe picture follows from relativity. But when it comes to stating plainly that time does not exist at the fundamental level, the language softens, the hedges appear, the qualifications multiply. And Carroll is one of the braver ones. Most physicists will not go even that far in public. They will discuss the problem of time at conferences among colleagues in the specialized language of their field. They will write papers that acknowledge the absence of time from the Wheeler-DeWitt equation, and propose mechanisms for recovering an approximate notion of time at macroscopic scales. But they will not look into a camera and say in plain language that the equation they have been working with for decades describes a universe in which you have never moved and nothing has ever happened. That sentence, stated plainly, is too heavy to carry in public, so they do not carry it. This is the scandal, not a conspiracy of silence, but a habit of looking away. An entire field of science has, in its possession, an equation that describes a universe without time, confirmed by experiment, consistent with relativity, consistent with quantum mechanics, and the response has been to work on other things and hope the problem goes away. It has not gone away. It has been here since 1967. It will be here tomorrow. It will be here in 100 years, because the equation is right, and the equation says the universe does not change. Stubbornly persistent. The illusion persists because it is built into the architecture of your brain. It persists because the Page-Wootters mechanism guarantees that internal observers will experience time even in a timeless universe. It persists because evolution shaped your neural circuitry to track sequences and anticipate futures and remember pasts. And that circuitry does its job whether or not the sequences and futures and pasts it tracks are features of reality or features of its own construction. The illusion is perfect, not because someone designed it to be perfect, but because any brain complex enough to ask, does time exist, is also necessarily a brain that experiences time. The question and the illusion come from the same source. You cannot have one without the other. There is a kind of vertigo in that, a recursiveness. You are a pattern in a timeless block, and the pattern contains a brain, and the brain generates the experience of time, and the experience of time is what makes the pattern feel like a life. Remove the brain, and the pattern is just a shape. Add the brain, and the shape becomes a story. The story is not real in the way you thought it was, but the story is all you have. You are inside it, and you cannot get out, and the inside and the outside are not separated by a barrier you could theoretically cross. They are separated by entanglement itself. The Page-Wootters mechanism does not trap you in the illusion. It is the illusion. The correlations between your brain states and the states of the things around you are the time you experience. Without those correlations, there is no time. Without the time, there is no you in the sense of a persisting, experiencing subject. There is only the pattern, the static, frozen, complete, total pattern. And the pattern does not know it is a pattern. It cannot know. Knowing requires a knower, and a knower requires time, and time is not in the equation. What the pattern does, what it has always done and will always do, is exist. At every cross-section, at every point along the world line, the brain in the pattern generates a specious present, a 3-second window of now, and within that window, it feels exactly like being alive. It feels exactly like this moment is real, and the previous moment has passed, and the next moment is coming. That feeling is not wrong, in the sense that it is not a malfunction. It is the correct output of a brain doing what brains do inside a timeless, entangled system. But it is not a description of external reality. It is a description of what entanglement feels like from the inside. So where does that leave you, sitting here at the end of this, knowing what you now know? The Wheeler-DeWitt equation was published in 1967. It describes a universe with no time. The Page-Wootters mechanism proposed in 1983 explains how a timeless universe can produce the experience of time through entanglement. The Moreva experiment in 2014 confirmed the mechanism in a laboratory. Einstein's special relativity, through the Andromeda Paradox and the Wright-Dike-Putnam argument, implies that the future already exists. Godel's rotating universe shows that general relativity permits time to loop, meaning linear time is not fundamental. Rovelli's thermal time hypothesis derives the arrow of time from thermodynamics and entropy, not from a fundamental temporal flow. The neuroscience of temporal perception shows that your experience of now is a construction, not a detection. And Julian Barbour, working alone for 30 years from a farmhouse in Oxfordshire, put the conclusion into words that nobody in mainstream physics has been willing to say out loud in public with the clarity the evidence demands. Time does not exist. You can reject that. You are free to reject it. The experience of time is so vivid, so unrelenting, so woven into the fabric of what it feels like to be conscious, that rejecting the conclusion is the most natural thing in the world. Every fiber of your experience screams that time is real, that this moment is special, that the past is gone and the future is coming. And you can choose to trust that experience over the equations. But understand what you are choosing. You are choosing the testimony of a 3-pound organ that evolution built to track predators and find food over the combined mathematical output of the most successful theories in the history of human thought. You are choosing the feeling of time over the physics of time. You are choosing the report of an internal observer who, by the Page-Wootters mechanism, is mathematically guaranteed to experience time even in a universe where time does not exist. The feeling is not evidence. It is the thing the equations predict you would feel in a timeless universe. It is not a counter-argument. It is the phenomenon that needs explaining. And the explanation is the Wheeler-DeWitt equation, and the Page-Wootters mechanism, and the Moreva experiment, and the block universe, and the thermal time hypothesis, and 50 years of converging evidence from physics, philosophy, and neuroscience. And the version of you hearing those words, and the version of you that existed before you clicked on this video, and the version of you that will exist after you close this tab and go about the rest of your night, are not 3 stages of one thing. They are 3 cross-sections of a 4-dimensional shape in a static block of space-time, 3 slices of a geometry that does not move. 3 patterns in a wave functional that satisfies h psi equals 0 and has satisfied it, if satisfied even means anything without time, in a permanent, frozen, complete, unchanging, total description of everything that is, was, and will be. Bryce DeWitt wrote that equation at his desk, probably in Chapel Hill, North Carolina, sometime in the mid-1960s. A man in his early 40s with a wife and 4 daughters and a career built on a question that most physicists considered unanswerable. He carried the name DeWitt because his birth name, Seligman, had made him a target in post-war Europe, and the name change had cost him a position at Stanford thanks to the fury of Felix Bloch. He ended up at Texas instead, which is where he built his career and trained his students and wrote the papers that would define canonical quantum gravity for half a century. He received the recognition he deserved only at the end of his life and after it. He died in 2004. In the framework his equation describes, he did not die. He is still there, at his desk in Chapel Hill, at the Institute for Advanced Study, meeting Cecile for the first time, at Harvard, 16 years old, beginning a path he would never leave. All of it, all at once, permanent. And Einstein is still writing his letter to Besso's family on March the 21st, 1955, less than a month before his own death, still writing the words that told a grieving family what his physics had led him to believe, that the separation between them and Michelle was not real, that the distinction between past, present, and future is an illusion, however stubbornly it persists, that people like them, who believe in physics, know this. People like us. The calculations have been done. The experiments have been run. The equation sits there, h psi equals 0, describing a universe that does not change. And your experience of time passing, The feeling you have right now that this moment is real and the previous one has gone is not evidence against it. It is predicted by it. The Page-Wootters mechanism says that internal observers in a timeless universe will experience time. You are an internal observer. You are experiencing time. And the universe, seen from outside, does not move. There is no outside. You cannot get there. Nobody can. The external perspective that would reveal the timelessness of the whole is by definition inaccessible to any observer embedded in the system. You will live your entire life inside the illusion, experiencing every moment as now, experiencing every memory as evidence of a past that flowed forward to produce you, experiencing every anticipation as evidence of a future that has not yet arrived. The illusion will be flawless. It will be seamless. It will be indistinguishable from reality because, from the inside, it is reality. The only difference is that now you know what it is. You know that the equation has been checked. You know that the experiment has been done. You know that the lines of evidence converge from quantum gravity and special relativity and general relativity and thermodynamics and neuroscience, all pointing at the same conclusion, the conclusion that Bryce DeWitt published in 1967 and that Julian Barbour has been arguing from a farmhouse for over 40 years, and that Einstein whispered to a grieving family in a letter written less than a month before his own death. The conclusion that the distinction between past, present, and future is an illusion, that the universe is a static, frozen, timeless structure, that you are a pattern in that structure, that the pattern does not move, and what it is a frozen pattern mistaking itself for a story.